Hey guys, hey, good morning to one and all person here. Okay, so far we solve the problems in continuous beams and in portal frames by using strain energy method. Okay, so today we are also going to solve the uh, calculation of redundant force by using strain energy method in trusses. Okay, so before going to that topic, first we have to know how to calculate the degree of redundancy. Okay, so these are the examples. Okay, so first they gave a frame. Okay, so this is a simple frame. Okay, so in this support A, okay, so support A is a hinge support and support D is a roller support. Okay, so for this frame we are calculating internal redundancy and external redundancy. Okay, so after adding these two redundancy, after adding internal redundancy and external redundancy, it gives total degree of static indeterminacy. Okay, so internal redundancy is denoted by I, and external redundancy is denoted by IE. Okay, so total degree of static indeterminacy is denoted by capital I. Okay, so for calculating, first we have to calculate internal redundancy. So internal redundancy depends on the number of members. Okay, so for calculating internal redundancy, the formula is m minus 2j minus 3. Okay, so m denotes number of members, j denotes number of joints. Okay, so in the particular figure, okay, so there are five members: member 1, 2, 3, 4, and 5. So number of members are 5, so m is equal to 5, and joints 1, okay, 2, 3, 4. 4 joints, so j is equal to 4. So after substituting the values, okay, m is equal to 5 and j is equal to 4, we are getting IIS is 0. Okay, so the given problem or the given figure is of a 0 degree of internal redundancy. Okay. Next, we are calculating external redundancy. So external redundancy depends upon the support reactions. Okay. So external this is hinge support and this one is roller support. So hinge support means two reactions will act and roller support means one reaction. Okay. So total number of reaction acting in the given problem is 3, and we are having equilibrium equations also 3. So smaller. Okay, so for calculating sectional redundancy, the formula is small r minus capital R. IE is sectional redundancy. IE equal to small r minus capital R. Small r is number of reaction in the given problem. So that is 3. So hinge support 2, roller support 1. So total reaction 3. Capital R is number of equilibrium equations. So number of equilibrium equations also 3. Summation H is equal to summation V is equal to summation M is equal to. So that is equilibrium equation. So 3 minus 3 is 0. So therefore, total degree of static indeterminacy capital I is equal to II plus IE. So II value is 0, IE value also 0 for the first given figure. Okay. So therefore, the total degree of static indeterminacy is 0. So the given problem or the given figure, okay, the first one is of indeterminate structure only. It is not indeterminate structure. So in both internal redundancy and external redundancy and all is 0. Okay, so it is determinate. Okay, now we'll see the second figure. Okay, so second figure, members, member 1, member 2, 3, 4, 5. So here also the member 5 members. Okay, so joint 4 joints, 1, 2, 3, 4. So 4 joints. So automatically IA will be 0. Okay, so after substituting in those formula, we're getting IA as a 0 only. So in this also it has two supports. Okay, this one first support is hinge support and the second support is roller support. So total number of reaction acting in the given problem is 3. Okay, total number of reaction is 3. So and we are having equilibrium equations also 3. So IE equal to 0. So the total degree of static indeterminacy for the second figure is also 0. Now we'll see the third one. Okay, so in third figure, we are having 3 supports. Okay, so first support, second one, and third one. Okay, the first support is hinge support. Similarly, second support is also hinge support, and third support is roller support. Okay, so hinge support means 2 reactions. Here also 2. So 2 plus 2, 4. So 4 plus 1, 5. So number of reaction acting in this figure is 5. Okay, So small r is equal to 5. So capital R equilibrium equation is 3. So r minus r. So 5 minus 3 is equal to 2. Okay. So in external redundancy, the degree of redundancy is 2. So based on members, okay. So now how many members are here? Member 1, 2, 3, 4, 5, 6. So totally 6 members are in this figure. Okay. So M is equal to 6. So joins 1, 2, 3, 4. So 4 joints only in this figure. This is not a joint. Okay. So 4 joints only. Joint 1, 2, 3, and 4. 4 joints. So J is equal to 4. So IA is equal to, we know the formula M minus 2J minus 3. So M is 6, J is 4. So 2 into 4, 8. 8 minus 3, 5. So 6 minus 5, 1. So degree of internal redundancy is 1. Degree of external redundancy is 2. Okay. So total degree of static indeterminacy is 3. Okay. So in this problem, in this figure, so total degree of static indeterminacy is 3. Okay. So next figure. So in next figure, members, member 1, 2, 3, 4, 5, 6. Okay, 6 members. Joints also same 4 joint. 1, 2, 3, 4, 4 joint. This is not a joint. So J is equal to 4. So we know the formula I is equal to M minus 2J minus 3. So 6 minus 2 into 4, 8. 8 minus 3, 5. 6 minus 5, 1. So I value will come as 1. So here there are two supports only. Both the two supports are inject supports. So number of reactions will be 4. Okay. So these two supports are inject supports. So two reactions will be there, are vertical and horizontal. So 2 plus 2, 4. So small r is equal to 4. Capital R is equal to number of equilibrium equation 3. So 4 minus 3 is equal to 1. So 1 plus 1 is equal to 2. So the given problem, that is 4. Problem number 4 is of static indeterminacy of 2. And the next problem, problem number 5. Okay. So member 1, 2, 3, 4, 5, 6, 7. Okay. So there are totally 7 members are there. Okay. I'll count once again for you guys. So this is member 1. Okay. Member 2, member 3, member 4, member 5, member 6, member 7. So there are totally 7 members in the given figure. So M is equal to 7. So joins. So joint 1, 2, 3, 4, and 5. Okay, so 5 joints are there. So J is equal to 5. So IA is equal to M minus 2J minus 3. So M is 7. Joint J is equal to 5. So 2 into 5, 10. 10 minus 3, 7. So 7 minus 7, 0. So in this problem, okay, so problem number 5, the internal redundancy is 0. Okay. And IE, first, next we have to calculate external redundancy. External redundancy is small r minus capital R. So small r is number of reaction in the given problem. So this support is inject support. This one is the roller support. So inject support means 2 reactions. Roller support means 3 reactions. So 2 plus 1, 3. So small r is equal to 3. Capital R is equal to number of equilibrium equations. That is also 3. So 3 minus 3, 0. So IE is equal to 0. So total degree of static indeterminacy is 0 plus 0 is equal to 0. Okay. In next problem, okay. So previous 5. So next problem, sixth problem is different from previous 5 problems. Okay. So in previous 5 problems, there are support. They gave the supports, maybe inject support or roller support and all they gave. Okay. But the sixth problem, the structure is fixed to the wall itself. Okay. So we are considering this as a fixed support. Totally, it is a fixed support. Okay. So there are only 3 reactions will act. Okay. Because of this fixed support, totally. Okay. Totally, we are considering as this as a fixed one. So fixed means only 3 reactions will act: vertical force, horizontal force, and moment will act. Okay. So number of reaction in this given problem is 3. Okay, small r is equal to 3. Capital R is equal to number of equilibrium equation. That is also 3. So 3 minus 3 is 0. Okay, that only they mentioned here. IE equal to 0. Okay, then IA is equal to, for IA calculation, we need to know M and J, the number of members. So member 1, member 2, member 3, member 4, member 5, member 6. So totally 6 members are acting here. We should not consider this as a member. Okay, this is a fixed support. Okay, without considering this, we have to consider others. Okay, this is member 1, member 2, member 3, member 4, member 5, and member 6. Okay, totally 6 members are in the given figure. So m is equal to 6 joints. So joint also we should not consider this as a joint, this one as a joint or this. Okay, this one as a fixed support. So we should not consider this as a joint. Okay, so this one joint 1, joint 2, joint 3. Okay, totally 3 joints are acting here. Okay, 3 joints are in this problem. Okay, so J is equal to 3. Okay, the formula will change. Okay, in previous cases for calculating IA, the formula will be m minus 2j minus 3. But in this case, IA is equal to m minus 2j. Okay, so m is 6, j is 3. So 6 minus 2 into 3, totally the 0. Okay, 6 minus 6, 0. So IA is equal to 0, IE equal to 0. So total degree of static indeterminacy capital I is equal to 0. Okay. So same kind of problem only, problem number 7 also. Okay, it is fully fixed support one. Okay, so number of members, member 1, 2, 3, 4, 5, 6, and 7. Okay, so total members are 7. M is equal to 7. Join 1, 2, 3. Okay, 3 joints are here. Okay, we should not consider this as a joint, and similarly like this also, this one also we should not take it as a joint. Okay, so j is equal to 3. The formula is II is equal to m minus 2j. So 7 minus 2 into 3, 6. 7 minus 6, 1. Okay. So in the given problem, this problem is of a static indeterminacy. Internal redundancy is 1. Okay. Then IE is equal to, okay, number of reaction acting in this problem is 3 because this is totally fixed. So small r is equal to 3, capital R also is equal to 3. So 3 minus 3 is 0. So 1 plus 0 is equal to 1. So the given problem is of a static indeterminacy of 1 degree. Okay. So the next problem, okay, next problem is similar to the first to 5 problem. Okay, so this is not fixed support. Okay, this is an injured one and this is one roller one. So the formula IA is equal to m minus 2j minus 3 we have to use. Okay, if the supports are totally fixed, means the formula is changing. Okay, the formula for calculating internal redundancy is m minus 2j. Okay, okay, come to this problem. So in this problem, number of members. Okay, first we have to calculate number of members. So member 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so totally 11 members are in this member, in this structure. Okay, so m is equal to 11. And joints. Okay, so joint 1, joint 2, joint 3, joint 4, joint 5, joint 6. So, okay, the 6 joints are acting in this. 6 joints are there. Okay, so j is equal to 6. So m minus 2j minus 3. So 11 minus 2 into 6 minus 3. So 2 into 6, 12. 12 minus 3, 9. So 11 minus 9, 2. Okay, so the given problem is of a static internal redundancy of 2 degree. Okay, so next we have to calculate external redundancy, small r minus capital R. Small r is number of reaction in the given problem. So inject support 2 reaction, roller support 1. So total number of reaction is 3. So 3 minus 3 is 0. Okay, so the given problem is of a external redundancy of 0 degree. Okay, so 2 plus 2 is 2 plus 0 is equal to 2. Okay, so finally the total degree of static indeterminacy of the given problem is of 2 degree. And finally, ninth problem. Okay, so ninth problem, it is fixed one. Okay, so this is totally fixed support. Okay, so then the formula is changing. IA is equal to m minus 2j. So number of members, member 1, 2, 3, 4, 5. So totally 5 members, m is equal to 5. Join. So we should not consider these points and all as a join. Okay, only one join. Okay, that is this one. So this is join. Okay, so m is equal to 5, j is equal to 1. So formula m minus 2j. So 5 minus 2 into 1. So 5 minus 2, 3. Okay, so the given problem of is of internal redundancy of 3 degree. Then IE is equal to small r minus capital R. Small r is number of reaction. So this is fixed support. So therefore 3. So 3 minus 3, that is 0. Okay, so finally total degree of static indeterminacy capital I is equal to 3 plus 0 is equal to 3. Okay, so the given problem is of static indeterminacy of 3 degree. Okay, so problem number 10 is also similar to problem number 9. Okay, so we have to use IA is equal to M minus 2J as the formula. Okay, because the support is fixed one. So number of members 1, 2, 3, 4 members. So M is equal to 4, joint is equal to 1. So 4 minus 2, 2. So indeterminacy is 2. Static external redundancy is 0. So 2 plus 0 is equal to 2. Problem number 11. So there's a truss only. Okay, simple truss. And one more truss also. It is invertedly placed in the primary truss. Okay. So number of members. So this is number 1. This is number 2, 3, 4, 5, 6, member 7, member 8, member 9. So totally 9 members are in this truss. Okay. So M is equal to 9. So joint. So joint 1, 2, 3, 4, 5, 6. Okay, so totally 6 joints are there. So J is equal to 6. The formula IA is equal to M minus 2, J minus 3. So M is equal to 9, J is equal to 6. So 9 minus 2 into 6 minus 2 into 6 minus 3. So 2 6 are 12. So 12 minus 3 9. So 9 minus 9 0. Okay, so the given problem is of internal redundancy of 0 degree. Next, we have to calculate external redundancy, IE. So IE is equal to small r minus capital R. So small r is number of reaction in the given problem. So in this inject support and this one is roller support. So inject support 2 reaction, roller 1. So 2 plus 1, 3. So small r is equal to 3. Capital R is equal to number of equilibrium equation. That is also 3. So 3 minus 3, 0. So IE is equal to 0. Finally, static indeterminacy, total degree of static indeterminacy, IE is equal to 0 plus 0 is equal to 0. Okay. So the given problem is of 0 degree of static indeterminacy. Okay. So these are trusses. Previously, in continuous beams, we used one formula for calculating the degree of static indeterminacy, and after that, in plane frames and all, we used one formula. Okay, so that is a external redundancy formula only we used. But if trusses means, okay, we have to use this formula also. Okay, internal redundancy. Okay, the problem is a truss means we have to use both the formulas, okay, for calculating the internal redundancy and external redundancy. And finally, we have to add these two, okay, for getting a total degree of static indeterminacy. Okay. So next topic is method of solving redundant frames or truss. Okay. So these are some methods are available. Okay. The first method is matrix flexibility. Second one, matrix stiffness. Third one, Maxwell's unit load method. Fourth one, Castigliano's strain energy method. Okay. So out of these four, we'll see strain energy method only because our first unit is strain energy method only. So we all know so what is strain energy, and we all know the formula for strain energy also. So what is the symbol using for denoting the strain energy and all? We know. Okay, we studied in the previous semester and itself. So for denoting strain energy, which symbol we are using? Sivakritika, are you there?
Yes, sir.
Hmm.
U, sir. Strain energy is the U, sir.
Okay, capital U. For denoting strain energy, we are using capital U. So what is the formula?
Summation P square L by
Actually, we studied in the previous semester itself for calculating the strain energy. The formula is U is equal to some sigma square L by 2E. Okay, sigma is nothing but stress only. So stress is nothing but load by area. So here they're mentioning it as in that load by area. So P square L by 2AE. Okay, so a stressed member carries a strain energy of P square by L, P square L by 2AE. Okay, the strain energy. Okay, where P is the tension or compression in the member. That's the total strain energy stored in the pin jointed frame, be it determinate or indeterminate, is given by, okay, U is equal to summation P square L by 2AE. Okay, we know this is the strain energy formula. Okay, sigma square L by 2E. Here that they mentioned in load, that is P square L by 2AE. So we are now saying in trusses. So trusses consist of number of members. So each member has its own strain energy. So finally, the total strain energy is summation of P square L by 2A. Okay. So for that purpose only, they are using summation. Okay. So in trusses, they are composed of number of members or joined out of a number of members, and each and every member there will be a strain energy. Okay. For getting total strain energy in the trusses, we have to add all those strain energy. Okay, so that only we are using summation. So U is equal to summation P square L by 2AE. Okay, so Ashwin asked a doubt. Okay, what is the formula for calculating internal redundancy? Okay, so our calculating internal redundancy, the formula is IA is equal to M minus 2J minus 3. Okay, if it has a support like this, okay, if it is properly supported. The one end is supported by means of rigid or roller support. So in that case, the formula for calculating internal redundancy is M minus 2J minus 3. If the structure is fully fixed to the wall, okay. So these cases, okay, in these cases, in problem number 6, problem number 7 and all, the structure is completely fixed to the wall. Okay, so this is a fixed support. In these cases, the formula is getting changed. Okay, that is IA is equal to M minus 2J. Okay, so this that is the difference. Okay, the formula for calculating internal redundancy is IA is equal to M minus 2J minus 3. Okay, suppose if the total structure is fixed to the walls, mean the formula is IA is equal to M minus 2J. Okay. So, the strain energies of Castigliano's theorem only. Okay. So, here the Castigliano theorem states that in any indeterminate structure, okay, in any indeterminate structure, the indeterminate forces take such values as to make the total strain energy a minimum. Hence, dou u by dou t1 is equal to dou u by dou t2 is equal to, it goes beyond up to dou u by dou tn, that is equal to 0 for all n values. Okay. So they'll ask Castigliano's theorems also. Okay, in this unit, they'll ask a define Castigliano theorem, or what is meant by Castigliano theorem, how it is connected to strain energy. Okay, there are three Castigliano's theorem. Okay, Castigliano first one, second one, third one. Okay, so all those are related to strain energy only. Next, we'll solve a problem. Okay, so a braced cantilever truss is loaded as shown in figure. All the members are of the same material. Okay, so all the members are of the same material. If it is made of steel, means so all the members are made of steel. Okay, so all the members are made of steel and have the same cross sectional area. Find the axial force in the member AD. Okay, so find the axial force in the AD. They are asking what is the member force in the member AD. Okay, so we have to calculate that one. The first step is we have to calculate degree of static indeterminacy. Okay, so we have to check both. Okay, internal redundancy and external redundancy also. So first we calculate external redundancy. So there are two supports. Okay, at support E and support A. Okay, the support E is injet support and support A is roller support. Okay, so injet support means 2 reaction, roller support means 1. So total number of reaction in the given problem is 3. That is small r is equal to 3. Capital R is equal to, that is also 3. Okay, number of equilibrium equations. So small r minus capital R, so 3 minus 3, that is equal to 0. So the given problem is of a 0 degree of redundancy, external redundancy. Okay. Next, we have to calculate internal redundancy, that is IA. Okay, so in this case, the formula is M minus 2J minus 3. Okay, here it has a separated supports. Okay, the given structure is not fixed to the wall. Okay, it is separated by supports only. Okay, So the formula is m minus 2j minus 3. So we have to calculate m, j and all. So m is nothing but number of members. So member 1, e to d number 1. Okay, member 2, member 3, member 4, member 5, and member 6. Totally 6 members. Okay, 6. Then this one 7. And they count this also. Okay, member 8. Eighth member. Okay, I'll count once again. So e to d member 1 and D to C is as a member 2. This one as member 3. This one member 4, member 5, member 6, member 7, and member 8. Okay, there are totally 8 members in the given structure. And joints, okay, joint 1, joint 2, joint 3, joint 4, and joint 5. Okay, so J is equal to 5. So formula is m minus 2j minus 3. So 8 minus 2 into 5 minus 3. So 2 into 5, 10. 10 minus 3, 7. So 8 minus 7 is equal to 1. So the given problem is of 1 degree of internal redundancy. External redundancy is 0. So therefore, total degree of static indeterminacy is equal to capital I is equal to IA plus IE. So IA value is 1, IE value is 0. So 1 plus 0 is equal to 1. Okay. So the given problem of is of 1 degree of static indeterminacy. Okay. Which that means, okay, static indeterminate or redundancy. So redundancy means excess. We all know what is the meaning for redundancy. That is X. So in this problem, okay, the redundancy is of number of members only, internal members only. Okay, then we have to remove that excess member. Okay, so in the question itself they gave, okay, find the axial force in the member AD. So we are considering the member AD as a redundant member. Okay, first we have to make the structure as a determinate structure. Okay, for making the determinate, the given problem as a determinate one, we have to remove the member AD. Okay, so after that we will calculate the member forces. Okay, and we'll calculate the member force in AD. Okay, so we considered member AD as a redundant. Okay, so the force acting in the redundant member is termed as redundant force. Okay, so solution, the first step is we calculated the static degree of static indeterminacy, that is 1. Okay, so next the truss is externally determinate and internally indeterminate. Okay, that is IE equal to 0. Here IA is equal to 1. Okay, internally indeterminate to the first degree. Okay, treating the member AD as redundant. Why we are treating AD as a redundant means in the question they are asking the axial force in the member AD. So that only we are considering the member AD as a redundant and removing the member AD. Okay, to make the total structure as a determinate, we have to remove the excess member. Okay, here we are considering member AD as a excess. So we are removing that member AD. So the primary structure is shown in figure. Okay, after removing member AD, the remaining structure is the primary structure. Okay, that is here. Okay, so applying a tensile force T at A, okay, and D along the member AD. Okay, so in the member of AD, okay, in the member direction of AD, we are applying a tensional force. Okay, here in this figure, here we are applying a tensional force in the direction AD. Here also a tensional force. Similarly, at the joint D also a tensional force. Okay, along the member AD, the truss is analyzed. Okay, so after removing the member AD, okay, and we are applying a tensional force along the member AD, the direction of AD, and we are calculating the member forces in the other members. Okay, so first step is we have to calculate the support reactions. Okay, there are two supports at E and A. Okay, load is also acting at joint B and joint C. Joint B 20 kilonewton and at joint C 50 kilonewton. So we can calculate the reactional forces. Okay, so by taking moment about point A or point E. Okay, so in this case they calculated moment about point A, taking moment about point A. Okay, so because of 20 kilonewton you'll get a moment, and because of 50 kilonewton also you'll get a moment. So what moment will get, clockwise or anti-clockwise? Ashwin,
Sir,
what moment will come here because of 20 kilonewton? What moment will here, clockwise or anti-clockwise at point A?
clockwise,
Clockwise. Okay, so and because of 50 kilonewton also
clockwise.
clockwise moment will occur at point A. Okay, is there any other force acting? At point E also reaction force will act because this is support now. So roller support means vertical reaction. Here the roller support is in the horizontal direction only. So an horizontal reaction will act. Okay. So at point A, we are considering 120 kilonewton. Okay. We are considering 120 kilonewton acting towards right. Okay. So for balancing purpose at point E, so point E is a hinged support. Hinged support means vertical reaction, the horizontal reaction will be there. Okay. So we are considering an force of 120 kilonewton acting towards right. For balancing purpose, we are considering the same value, okay, towards left hand side at point E. Okay. First, we have to assume this as a HA and this one as a HE. Okay, then only we'll calculate the value 120. Okay, you see this step. The taking moment about point A. Okay, so if we take taking moment about point A means because of HE. Okay, so HE is this. Okay, so we are considering a HE in left hand direction. Okay, left side direction. So because of if there is a force towards left side direction means what kind of movement will come here because of this HE anti-clockwise movement. Okay, Sivakrutika,
Sir.
now you are understanding. Are you understanding?
Yes, sir.
இப்போ லெஃப்ட் சைடில்
Yes,
இங்கே
sir.
வந்து பாயிண்ட் கீழே ஒரு லெஃப்ட் சைடில் ஒரு ஃபோர்ஸ் ஆக்ட் ஆகுது நம்ம அசியூம் பண்ணியிருக்கோம் பாயிண்ட் கீழே ரைட் சைடில் ஒரு ஃபோர்ஸ் ஆக்ட் ஆகிற மாதிரியும் பாயிண்ட் கீழே அது இந்த ரைட் சைடில் ஆக்ட் ஆகுறதுனால அது பேலன்ஸ் பண்ணுறதுக்காக இங்கே லெஃப்ட் சைடு பாயிண்ட் கீழே லெஃப்ட் சைடில் போடுறோம் ஓகேவா என்ன வேல்யூ நமக்கு தெரியாது ஓகே ஸோ லெஃப்ட் சைடில் வந்து
Okay, sir.
ஹெச்இ நான் நேம் பண்ணுறேன் இப்போ ஹெச்இனால பாயிண்ட் ஏக்கு என்ன மூமெண்ட் வருது கிளாக் வைஸ் ஆன்டி கிளாக் வைஸ்
Anti-clockwise, sir.
ஆன்டி கிளாக் வைஸ் ஸோ தட் ஒன்லி வி புட் ஸோ minus HE into 3, okay, plus 50 into 6. So 50, because of 50 kilonewton, we are getting clockwise movement only. We'll get clockwise movement at point 6. So plus 50 into total distance. Okay, distance they gave it as 3 meter, 3 meter. So 50 into 6. Again plus, okay, because of 20 kilonewton, we'll get clockwise movement. So plus 20 into 3. Distance is 3. Okay, is equal to 0. So after simplifying this, we'll get HE value. So HE as 120 kilonewton. Okay, so we are getting positively. That means we assumed at point T towards left side only. So that is correct. Okay, so HE is 120 kilonewton acting towards left side. Okay, if this load is acting towards left means at point A there is one more force HA that is acting towards right hand side. Okay, so after calculating HE and HA, okay, then we have to calculate the member forces and all. Okay, by using method of joints. First they consider joint C, they take it as joint C. So where is joint C? So joint C is here. Okay, how many members are here in joint C? CD and CB. Okay, two members are there and one vertical reaction 50 kilonewton is also there. Okay, so that diagram is this. Okay, joint C. So in joint C, force CD member is acting. Okay, so in that member, you are naming the force as FCD. So CB member is also in joint C. Okay, that member also the force is acting. You are naming that force as FCB. And vertical reaction, downward reaction, 50 kilometers there. Okay. Yeah, before that we have to calculate the angles also. Okay. So horizontal span length of AB is 3 meter. Similarly, the vertical height is also 3 meter. So automatically the angle is 45 degree. Theta is equal to tan inverse of, okay, by using that formula we can calculate the angle. Okay, so tan inverse of 45 1 means that is 45 degree. Okay, so theta is equal to 45 degree, 45 degree. Okay, here we are assuming the force direction, okay, away from the joint C. Okay, FCDY, just assumption only. Okay, if we get positive value means the assumption direction is right. Suppose if we getting negative value means the assumption direction is wrong. Okay. So we are resolving this. Okay. First we are resolving vertically. Summation V is equal to 0. So FCD is acting upward. Okay. So FCD sine 45. Okay. Minus 50. Okay. Is equal to 0. So FCD value will get. Similarly, summation H is equal to 0. So summation H is equal to FCD cos 45 plus FCB. Okay, so it is a 0 angle. Say plus FCB only will come. Because of 50, no value. Okay, 0 only. So we'll get FCD and FCB value and all. Okay, FCD has 70.71 kilonewton tensile and FCB has 50 kilonewton compressive. Okay, so method of joints only we know method of joints and all. We already studied in third and fourth semester about the method of joints and all. Next, they are considering join D. Okay, they are taking join D. So join D means member DE, DC, DB. Okay, and all will come. Already we calculate forces in members CD or DC. Okay, we have take that force also. Okay, here you're getting as a equation F D is equal to 50 minus 0.707 and FDB is equal to minus 50 minus 0.707 T. Okay. So after that, here the unknowns are there. Okay. Next, we have to take joint C, joint B. Okay. So in joint B also, we have to draw the free body diagram. Okay. And we have to constrain the force acting in those members in which direction the forces are acting. Okay. And then we have to resolve vertically and horizontally. We can then we'll calculate the member forces. Here also we are getting as a equation only. Okay. FBE is equal to 98.99 plus T. FBA is equal to minus 120 minus 0.707 T. Okay. So because of the we are in the member AD direction, we are considering a tensional force. Okay, acting, and we are naming the tensile force as a T. Okay. So we are getting those unknowns. Okay, we are getting it as a equation. If suppose we consider a unit force means we'll get a value 98.99 plus 1 means we'll get the value. We considering as a T only. So we are getting as a equation only. Okay. So finally, we are taking joint A. Okay. We have to draw the free body diagram for joint A and we have to calculate the remaining member forces. Okay. FAE is equal to minus 0.707 T. Okay. So we have to calculate the member forces only. Okay, after removing member EAD, then the total numbers are in the given structure is 7. We have to calculate all the forces in those 7 members. Okay, so after calculating, then we have to substitute. Okay, in the table of problem. So member. Okay, the serial number member. We are naming that member A B B C C D D E. Finally, the redundant member EAD. Okay, then F force F in kilonewton. So we have to substitute or we have to put the value what we calculated. Okay. For member AB, the value is minus 120 minus 0.707 T. Okay. For member BC minus 50. Similarly, for all the members, we have to put the values. For the last number, redundant number, we name the redundant force as a T only. Okay. The next step is dou F by dou R. Okay. So that is a differentiation. Okay. Dou F by dou R. Okay. The one minus 120 minus 0.707 T. Okay. So dou F by dou R is nothing but differentiating partially with respect to the redundant force. Okay. So R is nothing but redundant. Here we are considering the redundant as member as AAD. In that member, the force we are naming as T only. Okay, so this one only. So dou F by dou R means differentiating with respect to redundant. So here there is no redundant term, but in this second term there is a redundant T. So if we differentiate means we'll get the value as minus 0.707. So in the second term and third term 0. Finally in fourth member, that is member DE, dou F by dou R is equal to minus 0.707. Number EA also dou F by dou R minus 0.707. In member EB, the value force value is 98.9 plus T. Okay. So therefore, d dou f by dou r is equal to 1. Okay, differentiating. Okay, this t only will come. So dou f by dou r means differentiating t. Okay, that gives 1. So member BD, dou f by dou r minus 0.707. Finally, the redundant member AD, that is T. Okay, we only consider the T is the force. Okay, so dou f by dou r is equal to 1. Then we are substituting the length values of those members. Member AB 3, BC 3, CD 4.243. We have to calculate this value. Okay, other members value and all with the. So member AD 3 meter, BC 3 meter, vertical member also 3 meter, BD also 3 meter. We have to calculate the length of the inclined member. Okay, by using a Pythagoras theorem or hypotenuse kind of formula. Okay, square root of AE square plus AB square will give the member length of BE. Okay, so after calculating the member length, okay, so next column is F into dou F by dou R into L. Okay, we are multiplying these three terms, F, dou F by dou R, and L. Okay, so we are multiplying these three terms. Okay, and we are substituting those values in this final column, last column. So dou U by dou R is equal to 0. Okay, so strain energy in the redundant member, that only is 0. That is equal to summation F into dou F by dou R into L by AE. Okay, yeah, summation last column F into dou F by dou R into L. Okay, so we are summing all the values in the last column. Okay, so 1 by AE. Okay, 1 by AE. For all the members, AE is constant, so that only we took the AE as a constant commonly. So 1 by AE into 254.52 is the value of the first member AB. Okay, if we multiply these values, we'll get the value as 254.52 plus 1.5t minus 106.0. 0.05 plus 1.5t. Okay, so we are substituting the remaining values also. Okay, in the last column. Okay, and substituting, and we are getting the t value. Okay, is equal to 0. So t, we are getting t as minus 46.56 kilonewton. Okay, so that means the direction we assumed is wrong. Okay, so t, is the redundant force. So in which direction we assumed? We assumed in away from the joint. That means tensional force we assumed as a tensional force, but we are getting the value negative. So the assumption direction is wrong. Hence, the redundant force in the member AD as a compressive force only. Okay, that means the force act towards the joint. So the force in the redundant member AD is equal to 46.56 kilonewton compressive. Okay, Santosh,
Sir,
என்ன கண்ணா புரிஞ்சுதா? ஏதாவது டவுட் ஏதாவது இருக்கா?
yes, sir.
சொல்லுப்பா.
இல்லை சார், புரிஞ்சுச்சு சார்.
ஃபர்ஸ்ட் யூனிட் வந்து உங்களுக்கு சிம்பிள் தான். ஓகே, சிம்பிள் இந்த கேஸ்னா 3 டாபிக் தான் உனக்கு. பார்த்தீங்கன்னா ஃபர்ஸ்ட் யூனிட்ல கண்டினியூஸ் பீம்ஸ், பிளெயின் ஃப்ரேம்ஸ், ட்ரஸ்ஸஸ். ஓகே, இந்த 3 கேஸ் தான் இருக்கு. இந்த 3 கேஸுமே ஸ்ட்ரெயின் எனர்ஜி மெத்தட் யூஸ் பண்ணி சால்வ் பண்றோம். ஓகே, ஸோ எல்லாமே பார்த்தீங்கன்னா அப் டு 2 டிகிரி ஆஃப் ரிடனன்சி தான். ரிடனன்சி வந்து 2 டிகிரிக்கு மேலே போச்சு அப்படின்னா அவுட் ஆஃப் சிலபஸ். ஓகே, ஆனால் நீ ப்ராப்ளம் ப்ரொசீட் பண்ணா மட்டும்தான் மார்க் தருவாங்க, கிரேஸ் மார்க். இல்லை சும்மா கொஸ்டின் நம்பர் மட்டும் எழுதுனீங்கன்னா மார்க் கிடையாது. ஓகே, இப்போ ஃபர்ஸ்ட் கண்டினியூஸ் பீம் பார்த்தோம், அடுத்து ஃப்ரேம்ஸ் பார்த்தோம், அடுத்து ட்ரஸ்ஸஸும் பார்த்தாச்சு. ஓகே, ஸோ இது இப்போ சால்வ் பண்ண ப்ராப்ளம்ல ரிடனன்சி பார்த்தீங்கன்னா 1 டிகிரி. இந்த பர்டிகுலர் கேஸ்ல ரிடனன்சி வந்து 1 டிகிரி. ஓகே, அதாவது இன்டெல் ரிடனன்சி தான். ஸோ இன்டெல் ரிடனன்சிங்கிறது மெம்பர் வைஸ்ல. ஸோ இங்க எந்த மெம்பர் நம்ம ரிடனன்ட் மெம்பரா கன்சிடர் பண்ணியிருக்கோம்னா ஏடி. ஓகே, மெம்பர் ஏடி வந்துட்டு ரிடனன்ட் மெம்பர். ஏன்னா 1 டிகிரி அப்படின்னால ஒரு மெம்பர் தான் எக்ஸஸா இருக்கு. ஸோ அந்த ஒரு மெம்பர் எது அப்படின்னா ஏடி வந்து நமக்கு கன்சிடர் பண்ணியிருக்கோம். இது நம்ம கன்சிடர் பண்றதுதான் எந்த மெம்பர் வந்து ரிடனன்ட் மெம்பர்னு. இங்க கொஸ்டின்லேயே வந்து ஆக்சியல் ஃபோர்ஸ் இந்த மெம்பர் ஏடி கேட்டிருக்காங்க அப்படிங்கறனால அந்த மெம்பரை ரிடண்டன்ட் மெம்பர்னு கன்சிடர் பண்ணிட்டோம். சப்போஸ் கொஸ்டின்ல எதுவுமே கொடுக்கல அப்படின்னா நம்ம எந்த மெம்பர் வேணாலும் கன்சிடர் பண்ணிக்கலாம். எய்தர் டிபி, ஓகேவா, இல்ல இபி ஆர் ஏடி, ஏதோ ஒரு மெம்பரை நம்ம கன்சிடர் பண்ணிக்கலாம். ரிடண்டன்ட் மெம்பர்னு கன்சிடர் பண்ணிட்டு ப்ராப்ளம் ப்ரொசீட் பண்ணலாம். ஓகேவா. சம் கேசஸும் கொஸ்டின்லேயே கொடுத்துருப்பாங்க. ஓகே, இந்த மெம்பர் ரிடண்டன்ட் மெம்பரா கன்சிடர் பண்ணுங்க. சப்போஸ் இன்டர்மினசி வந்து 2 டிகிரின்னு கொடுத்தாங்க அப்படின்னா 2 மெம்பரை ரிமூவ் பண்ணணும். ஓகேவா, மெம்பர் ஏடி, மெம்பர் இபி. அப்போ 2 மெம்பர் ரிமூவ் பண்ணிட்டு நீ ப்ரொசீட் பண்ணும். ஓகே, இங்க ஒரு மெம்பர் ரிமூவ் பண்ணிட்டு ப்ராப்ளம் ப்ரொசீட் பண்ணியிருக்காங்க. ஓகே, ஸோ உனக்கு வந்து 2 டைம் இதே மாதிரி ஸ்டெப்ஸ் கன்னியூ ஆகும். ஃபர்ஸ்ட் வந்து ஒரு மெம்பரை வச்சுட்டு, ஓகேவா, ப்ராப்ளம் ப்ரொசீட் பண்ணணும். அடுத்து இன்னொரு மெம்பரை வச்சுட்டு ப்ராப்ளம் ப்ரொசீட் பண்ணணும். உனக்கு டேபிள் இருக்கலாம் 2 அண்ணா வரும். ஓகேவா, 2 இது வரும் 2 மெம்பருக்கு. ஓகே, ஏதாவது டவுட் ஏதாவது இருக்கா மோகன பிரியா?
சார் நோ சார், டவுட் இல்லை சார், புரியுது சார்.
ஓகே, மெட்டீரியல்ஸ் இருக்காம உங்களுக்கு? புக்கு வந்து சொல்லுங்க
சார் மெட்டீரியல்ஸ் நீங்க அன்னைக்கு அனுப்பிச்சுட்டது தான் இருக்கு சார்.
பிபிடி தான் இருக்கு, புக் எதுவுமே இல்லை ஸ்ட்ரக்சர் அனாலிசிஸ்க்கு.
நோ சார்.
சரி, நான் இந்த பிபிடி இப்போ அப்டேட் பண்ணியிருக்கேன், கொஞ்சம் ஆட் பண்ணியிருக்கேன், இதை அனுப்பிச்சி விடுறேன். ஓகேவா, ஸோ இதே ஃபாலோ பண்ணுங்க. இந்த புக்கு தான் உங்களுக்கு தரப்போறேன். ஓகே, இந்த புக்கு தான் உங்களுக்கு தரப்போறாங்க. இந்த பிபிடி உங்களுக்கு நான் குரூப்ல போடுறேன். இல்ல கூகுள் கிளாஸ் ரூம் கிரியேட் பண்றதா?
எப்படி இருந்தாலும் ஓகே சார்.
சரி, நான் கூகுள் கிளாஸ் ரூம் ஒன்று கிரியேட் பண்றேன். ஓகே, அதுல ஜாயின் பண்ணுங்க. அதுல அந்த மெட்டீரியல்ஸ்லாம் அனுப்புறேன்.
எஸ் சார்.
ஓகே, ஆஃப்டர்நூன் கிளாஸ் நான் தான் எடுப்பேன். ஆஃப்டர்நூன் எத்தனை மணிக்கு கிளாஸ் வச்சுக்கலாம்? இப்போ 11:20 11:30 ஆச்சு. ஆஃப்டர்நூன் வந்துட்டு 1 o'clock வச்சுக்கலாமா? விக்னேஷ் சரி, ஓகே, ஆஃப்டர்நூன் 1 o'clock கிளாஸ் வச்சுக்கலாம். ஓகே, 1 o'clock அதுக்கு முன்னாடி வச்சு சீக்கிரம் கம்ப்ளீட் பண்ணிக்கலாம். நான் குரூப்ல வந்துட்டு போஸ்ட் பண்றேன் எத்தனை மணிக்கு அப்படின்னு சொல்லிட்டு. ஆஃப்டர்நூன் வந்து ஜஸ்ட் எடுப்பேன். சரியா? ஓகேப்பா, கிளாஸ் கம்ப்ளீட் பண்ணிக்கலாம். தேங்க்யூ.
தேங்க்யூ சார்.
தேங்க்யூ சார்.
ஆ